So Jen asked me to talk today about diagnosing and correcting mathematical error patterns. So before we start, do we need any other introductions? Are we good for now? All right. So let's see. I think I got this to work this time. Why should we learn to track and diagnose errors? I think the biggest thing is knowing what errors students make over time, from year to year, semester to semester, can help us greatly strengthen the feedback that we plan to give students, where to spend our time. The most important thing I think that we'll see today is that the errors I'm talking about would be mostly individual errors. So something that we could design to give one-on-one feedback to a student. And knowing ahead of time where these might occur might help us set up ways or plans to deal with that as they arise. The other reason to diagnose errors individually for students is so that we can figure out what strengths that individual has based on the error they made. Just because it's wrong doesn't mean we should discount that they don't know that topic. And then studying error patterns more in a general sense across the whole class or from different instructors might help us look for something that would help us eliminate the error in general. I guess our plan today is I'm going to show you a couple of errors. I'd like you to try and focus on, for the examples I've given you. Oh, she handed it up. Put that hand out of the way, because I got one thing I want to check out halfway through the and then you can have it for reference at the end. But I'm gambling halfway through my talk. I got a little gamble going here. And I want to see if I got it right or not. So definitely take that home. Anything you want to talk, we can refer back to it later. But for now, let me turn it over. Our goal would be to plan instructional ideas that would build on the strengths that they have. So as I pull up the first example, we want to do that. And consider if something we may have said might have been the source of the error. Not by our intent, but because of the way it was heard. And I'm going to refer to this as overgeneralization. If we're not careful with our vocab, we'll say something, they'll hear something different, or they'll hear the important part of it, and it's just not going to work. So my first one, and this is all student work. I just photocopied, dragged the PDF onto the slide here. Now if it'd help, I can tell you the correct answer, but this is not the correct answer. Do you see what the student error is? How would you characterize it? What would you call it?
Place value.
Yeah, it's a place value error. So what would be an effective way of addressing this? Can we come up with a way or two that we would propose to address this place value error?
Every number you bring down, you have to have a digit for answer.
Well, and I think they did that. See, because what they hear is, for every number I brought down, I got a digit for the answer.
Yeah, but if you brought a 3, you got the answer, you brought the 3 down, and then you didn't carry the 0 up. And then you brought the 5 down without having an answer before you brought the 5 down.
Right. So I'm not disagreeing with them in any way, but you remember how a student might hear it might not be what we intend. They don't see the correct answer or the error. Any other things we could maybe do? Maybe a written technique instead of a verbal technique so that we don't have that confusion.
Use graph paper.
Use graph paper.
I would have the students do arrows. You can only use one arrow at a time. So you
Arrows
brought that 3 down. Can't take it in there, yeah, and then draw another arrow.
And personally, I like to hear this place value idea. I really, at the college level, something that's either missing or that they don't fully grasp is we teach them place value and then they never really use it. So to know that that's not 2 times 5 is 10, that's really 0.2 times 5 is 1. Then the place value idea. So we could look at, this is pretty much what you said, the graph paper idea. Almost all of our students have line paper. It's very easy just to turn it, use the line paper, turn 90 degrees. We don't necessarily need graph paper. This will make sure that when they do 7 times 5 and they get 35, if it was here, where our student was in error, that 35 would pop up over here. They'd still bring the digit down, they'd still put a number on top, but the 35 they would then recognize is in the wrong place. Another technique, and this I don't see many students at all using, but it's very powerful for teaching place values, a pyramid or a reverse stack technique. I don't know how common it is at your level or if you've even seen it. Most students, once they learn the place value, they stop writing it. But to really emphasize that this is not a 2, this is a 2. This is a 2. And for that example, I've removed the decimal. And this is my work. This is me showing instruction. So this isn't student work here. This is my writing.
Sometimes I think if they know to watch out for those kinds of errors and say, hey, you know what, here's where a lot of people goof up. Let me show you this. And I mean, I use that a lot, especially with stuff like that.
So exactly, some assessments must be made with error detection in mind. I had to know to look for this error. Now, I started again as a calculus instructor. I gave you more of my history last time we were here, but I really was a calculus instructor at the university, not even at the high school. And so this kind of work was not something I ever thought about teaching or instructing. It was, I took it for granted. If you're in Calc 2, you can do division. We don't talk about it. You know, so I would give division books, and when they hired me to be a pre-algebra teacher, I assigned problems out of the book. I read the book. I knew what I was doing. And for at least 2 years, I didn't cover these topics because they weren't in any of the 3 textbooks that were given to me as resources. Specifically, things with a 0 in the quotient. So, the previous example had a 0 in the quotient, and I'm saying that despite the resources that were provided to me, 3 6th edition textbooks or higher did not have a 0 in the quotient in a pre-algebra textbook that was that had a whole chapter on teaching long division, whole section, sorry, a section on long division. So we need to know what's there. I continually, now my role as a department chair and supervisor of all my non-tenure track adjunct instructors is to evaluate their assessment devices. Most teachers don't ask this question. They don't even look for the error. We need to know what's present there. And I've evaluated instructors who told me they were doing a good job of division, didn't assess them. I said, hey, try this. And of course, then they detected some errors that they didn't know were there. So sometimes a special case can give us some extra tools. And then it can be used to generate discussion. I've had more progress made in teaching place value using a technique that is either this technique or similar to this technique right here, where this is a 200, than I have with any of the other ideas I've ever seen for place value. So I can use division and their error, because as you can notice, this student, the student who made this error is computationally very sound. There's no error in choice of numbers. It's just a place value. But again, error diagnosis is not accidental. So I've got a different example up here. Really, I'm asking you, is this the same error or a different error? What do you think? We've got 4.9 divided by 2. He's ignored the sign over here. The sign's in the answer. That's great. Move the decimal like we see in a traditional algorithm. So I asked this student, and I now believe it to be a very different error, completely different. The decimal went to the end. Therefore, the decimal stays at the end. And even though he knew the concept of adding the 0, put it here, and didn't put it here, I still believe that if he put it there, he might have still put the decimal at the end with the way that he described the problem. Because he said, we move the decimal. I said, in this example, we move the decimal to the end. And the student overgeneralized, because I was talking very specific about that idea. So was it poor choice of words on my part? Quite possibly. But without the assessment done at that point, and then asking him about his error, including a decimal, may change the student thought process. We think of it as the same technique. but this is a different error from the one before it. So would our plan for instruction be the same? Line paper, stack algorithm, something different?
Maybe the line paper and having the decimal go directly on the line.
Yeah, that's exactly what I did for this one student, was the line paper. But that's also my fallback technique for all these errors. That one's my favorite. I've seen, there was another example I read about manipulatives, and I couldn't make it work effectively. So I think the line paper is the most powerful. And also because of my affinity for teaching place value, right? I'm tied to place value for different reasons. How about this one? I mean, does a student have strengths? What strengths can we build on? What are the student's main weaknesses? Now remember, 7 divided by 25. So they've added the zeros. They've got the decimal in the correct place up here. But it's absent down here, so we lose from reading the work in hindsight. So part of what makes our diagnosis difficult is we're seeing a snapshot after they've done it. Right? So we're not watching them go through the process. We don't know what order which numbers went on the paper. So in some sense, it's very tricky detective work. This student added the 0, but he added it both places. He added it above and below, and then multiplied by 8. I mean, the correct answer should be 0.28.
He also could have checked that the remainder was 20, and 20 is a pretty big number, so 25 doesn't go into 20.
Correct. Right. So you're saying, we're assuming that at this point here, he should have made the assumption about the 0?
Yes.
Yeah.
In other words, he was taking the 25 into the remainder of 20 and put the 0 up on top.
Now there's some other hints that this is not a strong student in general. What's the other hint that this student is not a strong student in general? He had to guess which way the division went. And I say guess because this was a 4-page assessment. And he wasn't very consistent. And that's an area that I'm struggling with on how to teach people, especially not first-time learners, who still consistently cannot get that error correct. And I don't have a solution strategy for that to share with you. I mean, I can teach them mnemonic devices, I can try and do examples, I can try and get them to memorize flashcards, but some students, that's still a major obstacle. And unlike the line paper, I don't have something I can point to that will help them do better. I would hope that number sense would do it, but it doesn't. So, again, I believe this is different. But my instructional plan for this student would probably be the same. So, how about this error? Now, the first one's correct, right? And these are problems number 26, 27, and 28. I omitted 27 just in the interest of space. The student did get 27 correct. It was another decimal multiplication. So the decimal multiplication is correct. Did you find out what they did? They got rid of the decimal because I taught them to do that for multiplication. Right, for multiplication, I said get rid of the decimal. Take 318 and multiply it by 5. That was my instruction, and I stand by that instruction. Because when they include the decimal in there, you should see what they write. It's pretty fantastic, right? I mean, you know what I'm talking about here? Like, I mean, I've got a student who will write a page of work because I was trying to be, I mean, I don't even think this was clever. I just did this problem because I was trying to teach the properties of 1. And we have on her paper this. because my brain doesn't even think that way. But she had 4 lines of work because she multiplied each of these things by 0. So you know the first line looks like, on her paper, 0.032, and then the second line looked like this, and then she had decimals over here, which of course wasn't student work to build on. So this was good. This student's actually a male, so that's a different student who had this problem. But do we see that they counted 3 decimal places? 1, 2, 3, got the 1.5. And then over here they did the exact same technique. So an overgeneralization error. What I did with multiplication will and does work with division. It's not true. So where is their strengths? Well, their strengths is they do know how to do long division. And they did it with whole numbers. That's good. And they know that decimal place value can be removed. So I had a very specific plan for instruction. Get rid of the decimal. But in a more consistent fashion. I said, we're never going to write this symbol ever again. Because this symbol simply doesn't exist in algebra. Right? It's a convenience for typing on a manual typewriter that should have died a long time ago. I can just as easily do this on my computer as I can do this. In fact, I got to the point where I can do this faster than that because I still can't find that thing on my computer. Right? Can you? Microsoft Equation Editor, biggest piece of I've ever, we were talking about this on the way out. It's hard to use, cumbersome, point and click. But the fraction is just as easy to type as this. I can expand their knowledge, talk about multiplication by 1 to rewrite it, and get back to where the student's strength is, division by a whole number. And it cleans up the work. We don't have those little hoopty-hoos under the division. That's a true fact that we can use in algebra later as an analogous task if we need to. All right. What about this error? You think it's common? How would you describe this error? How would you plan instruction? And does it appear in other areas of algebra that maybe is either creating the error or because of this error is impeding progress somewhere else? And I probably should have written arithmetic instead of algebra. So, do we see the error? We've doubled the product. The square applies to both the A and the C.
Yeah.
And then we got a copy in here. Right? So that's some sloppiness. That's not even what I'm looking for. I mean, I'm really, when I picked this example, I didn't even see that, right? Because my attention was drawn here, because that's an algebraic error. So that's the thing that needs to be instructed on. The sloppiness, can we, for the sake of argument, just ignore that sloppiness?
They still even actually
They
They still cancel correctly. And that is actually not uncommon at all, right? That they cancel correctly because they knew it was a B. And you know who does that a ton? Is my Saudi students. I have a disproportionate high number of Saudi Arabian students because MSU is strategically partnered with an institution in Dubai. And they know what to do. They know that they've had calculus. Their only struggle is language and writing new symbols, things that are foreign to them. And they'll do this all the time. They'll do this all the time. Okay. And so I think that that's a different error, and that's not the one I want to talk about. I want to talk about the one on the top. By the time they come to me, it's not all that common. How common is it for you?
Very.
Very?
Saw it today, polar equations.
There you go.
I gave them 3x squared plus y squared, no parentheses, and that became 3r squared because they saw the x squared plus y squared, and that's an r squared.
So it's a small mistake, but it's a fatal mistake in almost every example where it does happen. So how would we plan instruction? What could we do different? I think it is fairly common big picture. We see it in enough places. And I think for a student who's truly struggling with it, who's horribly inconsistent, we have to go back to numbers, factors, and writing writing out a whole bunch of things. Not at all unlike what we talked about at our very last meeting here. It has to be written out so that it's clear, and at some point it has to get long so that it's cumbersome, so that we're forcing that idea of let's pay attention to what the exponent means. Let's highlight similarities and differences. Where would we see AC? Make sure that we're clear. So both in our examples of what's right, but hey, this is what you thought it was, don't we know that that's a squared c squared?
I think it'd be important to make sure that you recognize when two of them are numerical too. Like if you're thinking of 23 squared, because I could see somebody thinking that 23 squared, because that does mimic their actual original problem.
And that error does happen, right? Especially for our, at least my weakest students, the ones with the least amount of practice in algebra. So I would think that for a high proportion of middle school students, that's got to be the case, right? Their first experience with exponents. And we don't want them to overgeneralize, because I'm going to tell my students that 3 only touches the x, it doesn't touch the 2. But if it was at 23, well then all of a sudden that falls apart. So absolutely, if we're at that beginning level, we need another example up there.
How come you went do parentheses AC squared to show them? Because that's what, I mean, the mistake was.
Because it matched their work. Okay. So what I did was to build on their strengths. I took this, wrote that, and said, kind of out of context, with that kind of out of view, hey, what's this? And they're like, why do you ask me that? It's a squared, c squared. And I go, well, why did you think, oh. So it's kind of a reverse process.
Because what I'm thinking is, they thought it was parentheses AC squared, and that's what they did.
Correct. And so my plan for instruction was, I would give them this. I would give them this. Say, hey, what is this? That's what you wrote. They would recognize that as a squared, c squared. And then we could go down to exactly what you said. I think that would continue our discussion. But I would start the discussion with their strengths. Hey, you wrote that. You know what that means. It means a squared, c squared. So that's why I didn't do it. And that's specifically why in this series of examples, I showed them something different first, and then what they had, and expected them to do it. Notice that this is, I'm kind of expecting you to read it this way. I didn't put a squared c squared equals AC. And I would not have given this to the student. They would have to fill it in. So it's just like that division example. It's hard to see someone else's work and see what they were thinking, the order and why that order is on the paper. Okay, so this is a student from the previous slide, the one we just looked at. This is a new student. Do they have the same error or a different error? Now, assuming that this is a B, that was my assumption all along, they're exactly the same, or are they? This is like the example with the 23. This student may potentially believe that AC is a thing. Look at the way they wrote it. They put dots between the things that they thought were factors. There's a dot between the C and the B. There's a dot between the AC and the AC. And there's a dot between the A and the B, but there's not a dot between the A and the C. I don't have a clue if this student knows what's going on or not. So error diagnosis has to have detection in mind. I had no idea when I wrote this exam that that could even happen. I didn't think about it. But while I was grading and tracking errors that students were making, I realized it was a bad question. I don't know if this previous student, I don't know if this student knows the answer or doesn't. And it turns out she didn't. She believed AC was one thing. I asked her that question, and the A's didn't cancel. She wrote AC again. So I let that error persist, because I didn't want to correct that error until I knew, through discussion, whether or not the A's canceled.
And she didn't cancel even one set of A's because she thought
Not initially. When I said, is that right, then she drew a line through it. But her first gut was a pause and to look at me, am I right? So if I would have not said anything, she might have canceled. Either way, there was hesitation in her mind. In fairness, it was a weird special case too. She had a concussion. I think this error is more common than we think it is, and I think it's directly tied to this example in arithmetic. And this assessment was given after the AC one. Actually, before and after. This is their only repeatable test in my class because I think this is an important idea, so I want to make sure they can do it right several times. We can't. So here we've got a mistake right here. -3 squared is -9. For the exact same reason. That's the same principle algebraically, it's the same examples I had from before, but I can't use these examples to address that topic. It doesn't work. So I need a different plan for instruction. It's the same basic principle to me as the instructor. The diagnosis is the same. They're misunderstanding the effect of the exponent, but the way I address it, the things above it won't address it. So I got to do this. I got to go back to right now factors. And here immediately I do the one with parentheses so that you can see the contrast. I think this has more value. I don't see a lot of my instructors doing that. And I see some gains. What was being doubled or what was being squared or what you write twice. There's all sorts of ways to say it are the parentheses. And the 3 kind of just tags along for the ride, and so does the sign.
Instead of using parentheses, why can't you use like n squared and go show it's n times n, and then substitute 3 and substitute the -3n.
Because too many of my students think this.
Yeah.
The same students who persistently score that error think this is true. They think that the absolute value of -x is x. Well, just
Why don't you go n squared equals n times n?
n squared equals n times n.
Now substitute 3n, substitute -3n.
Oh, absolutely. Yeah.
Because despite the fact that I teach them that when you substitute in, you should have parentheses, this is what I end up seeing. Now it's the exact same problem. So we could then, like the division example, say, hey, that's not how you substitute stuff in. Right? To substitute a variable in, you need parentheses where that variable was in order for the replacement to be correct. And so this is the place where we can really leverage a student error to see whether or not their variable replacement is correct and further instruction. So I do think that that is the right thing to do. I guess my gut is my experience. I don't start there because then I get distracted. But I don't often have a one-on-one environment. I think with a one-on-one environment, I think your solution would work just as good, if not better. And you get to leverage the idea of, are they putting the right parentheses down when they evaluate? I mean, that's huge. This assessment, the very next problem has that idea in it.
Why don't they like to use parentheses?
Why don't they?
Yeah.
They're lazy.
It clears up a lot of stuff.
Less you can write, the better like.
How come, Lisa? I struggle with this. So Lisa's the mathematician, right? The PhD mathematician in the room. And I've got those tendencies, but my students do not. I continue to write this example, and it makes me cringe every single time. I would much rather write parentheses around the -1, parentheses around the 3, and parentheses around the 3. But that's so foreign to them. Remember how foreign you thought it was when I showed you to write factors in the denominator of the fractions that you're going to add? I don't want to scare them. I don't know. Because, yeah, we should write parentheses every time we mean multiplication. Then there would be no confusion about what thing is. And if we were consistent, every exponent got rewritten with parentheses, we would know and we would reinforce what those parentheses are. But it's not standard in the textbook, it's not standard in the examples, it's not standard from the tutor note. We are up against some
you also have to find out whether the misunderstanding is the exponent or whether the misunderstanding is just what the negative sign means, I think.
It could, yeah.
Because there's a whole other level there that kids just sort of assume that's attached somehow magically, and it doesn't really, it's not really this separate -1 situation of a factor, it just is part of it.
And I'm going back to what Doug said. I don't always think super fast on my feet, but you know what? That's not a bad idea either, because it sorts out both of those things for us.
Yeah.
And I'm thinking to the assessment I pulled this on, my next one, the very problem after this order of operations style problem is an evaluate problem to see if they can add their own parentheses in the correct places. So I think they're related, because it's question number 1 and 2 on my basic skills assessment. All right, so I overheard somebody do this, because I supervise people all the time, and they just said this. -3 has 1 negative, because the exponent does not include the sign. So the answer is negative, but -3 squared has 2 negatives because of the exponent. So the answer is positive. That's kind of sloppy, right? But it's not necessarily wrong. I've said something similar before, right? That exponent touches the 3, not the negative. There's only 1 negative here. There's only 1 negative here, right? But over here, it's inside the parentheses. It's inside the parentheses, so we write it twice. There's 2 negatives. That's the negative one. This is the positive one. And it worked, right? Saw the teacher help the student. They got it right.
The first one has 3 products, second one has 2 products.
Yeah, products might have been a better choice. And the student did this one within 10 minutes and got it wrong. Because that exponent's got 2 negatives too, right? So 2 negatives is the positive. And that's true in multiplication, and you just said it was true in exponents. So again, if we're not super careful, I mean, it's easy to sit there and criticize someone else's work, but when we're talking fast, when I'm helping 3 students at once, because I rarely get one-on-one time with students. I'm either in the lab environment or in the classroom where I'm talking to everybody. So, we just got to be careful. I mean, what they hear, what we hear. And even if we said product, that would be great if that worked. So what's the error here? And how would you fix it?
Order of operations.
Order of operations? So what devices do we use? What would help? How do you help students with order of operations?
Are you talking about PEMDAS?
Yeah, PEMDAS. So PEMDAS will fix the problem? Anything else? So you said the error was PEMDAS, right? The error was PEMDAS.
The error was that they subtracted before he multiplied.
They also misunderstood that a number next to a parenthesis means multiply. Because to them it actually looked like they did solve it, if you go back to it.
So
It looks
go
to
back
them
to it.
like they did have the parentheses solved, so then all they had left to do was addition.
But I still think the error is PEMDAS. The error is PEMDAS. Here's another example. What's the error here? What is the error in this one?
Multiplication before division.
Which is?
Chem-
Which is PEMDAS.
When you write it that way.
Oh, yeah. It's circle.
And
Yeah.
guess what the student added in the previous example? Because there were no parentheses left to do first.
Was that the same student? Those
No,
students?
2 different students. I think the error is PEMDAS. So let me show you some data that I collected in January. Fojan said I had to talk about error analysis. I went around and asked what the #1 error in developmental math is. I heard it was order of operations. So, I started with 60 students this semester. They're all enrolled in pre-algebra at Montana State University. The question was posed on the 4th day of instruction. I walked into the room on the 4th day, and I said, what's 6 divided by 12 times 2? I actually didn't even say it, I just wrote it on the board. That wasn't that bad. Green is right, red is wrong, and yellow is completely wrong. Now I separated it into, I could have conglomerated my data, but I have a reason why I didn't. So this is my 12 o'clock class, my 1 o'clock class, my 2 o'clock class. Section A, B, and C. Absolutely no discussion or instruction. Walked in, here's your warm-up problem, what answers do you have? Hey, talk to your neighbor, because there's 2 different answers out there, 3 in some cases. Talk to your neighbor, help each other, and then let's take an official vote. Now there's some hidden things I'll tell you about in a minute here. But the orange one is different now. The orange is not another answer. This was, hey, how many of you do you know PEMDAS? So, in the class where the most students knew PEMDAS, they were the most convincing to their peers that they were right because they had a reason they were right, and the reason they were right was PEMDAS. This classroom is all traditional age students. There is not a student over the age of 21. I don't know how that happened. The university uses random enrollment. They're all in there. This class is predominantly, or at least, it is the heaviest non-traditional class I've taught. It's got about a third of people over 21. Meaning, they did something else in high school. They went to the Army, the Navy, jail. Those were the 3 I know. Decided to clean up their act, come back to college. The other 3 were single mothers over the age of 45. They did not remember even going to grade school. So they did not know PEMDAS, the lowest column of PEMDAS knowers. In this class, has 3 vets in it, but they're fairly traditional age vets. Right? You got to go straight into the Army, back out to college, so they're not older returns. So age has a little bit to do with it. The ones that came straight out of school do the worst.
But that also, you might get lucky with the fact that whether or not you're even familiar with math, you can just get lucky.
You couldn't
solve
believe
left to right,
how
left to
happy
right.
I was with this data, because I just rolled the dice. I was like, oh, I got to gather some data for Bojan here. What am I going to do? What am I going to do? And then I took this poll, and it came out pretty sexy. Now, this student here was retaking the course.
Oh,
Because she got sick before the final, went home, and didn't file for incomplete. So I don't think I can include her in my data set. I kicked her out of class after spring break. She's doing an independent study with me. She's going to finish on Monday. She's not in her peer group. First exam was about 5 days later. We talked about the order of operations. We did not use PEMDAS. We did other things. This question was missed out of 2 of the 60 people.